Hey everyone, this is a fun problem, dilutions problem. This will never go away. So this is also in your workshop or discussion worksheets. So being able to solve for molarities is really important. So we never want to forget the actual definition of what we're trying to solve for, which I've written out over here. So moles of solute versus liters of solution. And you can think of what those are differentiated by when you think about dissolving salt in water. I think many of us have probably done something similar, sugar in water. So your solute is typically those particles, the salt or the sugar. Your solvent is your water, and when you dissolve them completely and get like a homogeneous mixture, then you have your solution. So today it's asking what are the molarities of the following solute when dissolved in water. So you have this molecule, you have 57.5 grams in 525 milliliters of solution. So you'll notice that they're giving us grams and a volume. So here's your solute in solution. Okay, so we need to essentially figure out these two parts of the fraction separately if you want. So let's start at the first, the moles of solute, the numerator. We have grams, right? And we need to get to moles. So what is that conversion that we always need to do? In this case, it's molar mass. So we look at the molecule we have, I think it's acetone, CH3 to CO. So we've got, how many carbons? We have 3 carbons. We have 3 times 2 is 6 hydrogens and 1 oxygen, right? That's a 1, not a 10. So I'm just kind of rounding a little bit. So we have 3 carbons times its molar mass of 12. We have 6 hydrogens, molar mass of 1. And then we have 1 oxygen, and it's 16. So let's do some math. Don't be afraid of it. We have 36. We have grams per mole. We have 6 grams per mole. 16. Let's do even more math. So we have 6, 12, 18 plus 40. What is that? 58? See, you don't need a calculator. Okay. So we have something to work off of at that point to get the numerator. And what about the, yeah, let's do a little conversions for the denominator as well. So the milliliters of solution needs to be liters of solution, okay? So if we're starting with 525 mils of solution and we need to get to liters, conversions, dimensional analysis, we can go from milliliters to liters because you can cancel your numerator and denominator units and you get what you need. Now don't forget what this conversion is. How many milliliters are there in a liter? So we have 10 to the 3 is in 1 liter, or 1,000, a millennium, okay? So this moves the decimal over 3 times, 0.525 liters, okay? So that would be your exact denominator, 0.525 liters. So let's go back to the problem at hand. We are starting with 57.5 grams of that molecule, CH3 to CO. Using its molar mass, we are going to use this value over here. So we have 58 grams per mole. And let's see what we get. We get something close to 1, right? 57.5 divided by 58 is about 0.9913-ish. We're not going to round yet. That's your numerator. You're going to divide that by 0.525 liters. Okay, because that is the definition of molarity. And I ended up getting 1.8883. Capital M, or moles per liter. At this point, you need to round appropriately. So our problem has 2 numbers in them, right? Has the 57.5 and the 525, and those are both 3 sig figs. So we're going to stop at 3 sig figs for our problem at hand. Box it up and go home. So hopefully that was fun. I always thought it was fun. And I think I should be able to do one more video. We'll see.